Hey guys, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer test 2 questions. So altogether, we have 7 different questions and let's start with the first one. Question number 1. Determine the direction of the reaction if 1. The temperature is altered from 283 Kelvin to 300 Kelvin and 2. The pressure is altered from 380 m to 280 m. Let's look at the question one by one. So the first one, the temperature is being altered from 283 to 300 Kelvin. So it means that there are an increment of temperature. So the first thing that you need to check is your delta H. So in this case, your delta H is negative. It means that it is an exothermic reaction. So basically, when you increase the temperature, so increment of temperature, it will favor endothermic reaction. So since this is an exothermic reaction, so we can say that the increment of temperature shall make the direction of the reaction to move backwards. Means that it will move to the left, which will produce more reactant as compared to the product. Alright, moving on to the second part of the question. What if the pressure is altered from 380 m to 280 m? So it means that the pressure is being decreased. So when you decrease the pressure, it means that the reaction will favor the side with more gas. Right? When you decrease the pressure, so you decrease the pressure, it will have the probability to move towards the area or the side with more gas. Okay, let's see. So in your reactant, you have 1 plus 3 equivalent to 4. In your product, you only have 2. So which side have more gas? Definitely the reactant. So it shall move to the left as well. So because the left part, which is the reactant, have more gas as compared to the product. Let's move on to question number 2. Sketch an experimental setup to silver plate a stainless steel spoon and predict the electron movement in anode and cathode during the reaction. Alright, so in here, the question already gave you a hint where it says that it's going to silver plate. So it means that the process should be an electroplating process. So in an electroplating process, the first thing that you need to remember is that it needs a source of energy. So in this case, we need battery. So you have battery, and remember your battery, the way you write your battery, you need to know which one is the positive and which one is the negative. So cathode and anode, so which one is positive and which one is negative, alright? And then you need to put the wire, so here positive to negative, so means that your electron shall move down here. So which one that you need to put? So at the positive side, you should put your silver plate. So here you need to label the silver plate, and on the other side you need to draw your spoon. Right, so that is not all. You definitely need to put your electrolytes here. So this one is your spoon, right? So because this one is silver, so basically what we are going to do is we are going to use argentum nitrate as your electrolytes, right? So this is the first part of the thing. And then if you look at the mark, is 3 marks, right? So definitely, because here it says that predict the electron movement. So you need to say the electron movement. So the anode shall oxidize to form the cation, which shall be deposited to the cathode. So you need to write, so your anode, the half reaction for anode is you have silver, argentum, so you donate electron, so you shall produce the argentum ion, means that this one is the oxidation from 0 oxidation number to positive 1. And then you need to write at the cathode, this ion that is being formed, and also the dissociation of your electrolytes. So the ion, the argentum ion, will accept electron, therefore it will produce argentum in solid form that will be deposited on your spoon. Alright, so you need to write this half reaction. Many of you forgot to write this half reaction. You only draw this, and some of you don't even put the correct symbol for the battery. Right, let's move on to question number 3. So the Kp for the reaction of 2NH3 to produce N2N3H2 is 1.5 times 10 to the power of 3 at 400 degrees Celsius. So calculate the Kc for the reaction of N2, 3N2 plus 9H2 to produce 6NH3. So I guess this is a rather challenging question. So if you can see here, you have two different equations. One is 2NH3 will produce N2 plus 3H2. But the thing that you were asked to calculate is for 3N2 plus 9H2 that will produce 6NH3. Alright, so how are you going to tackle this question? First thing, you need to realize that the equation that you were asked to calculate is actually the opposite side of the one that you have at the beginning of the question. And then another thing is that this equation, after it's being switched, it is being times 3, right? So you times 3, so you will get like 3 times 2 equals to 6, and then 3 times 1 equals to 3, and 3 times 3 equals to 9. So you need to aware of that fact first. So it means that you can't use the value of Kp around here yet, because you need to have a new value of Kp that will represent this equation. So how are you going to find the new Kp? Right? Okay. The concept is that because you are swapping the sides of the equation, so in order for you to find the Kp is 1 over the original Kp. And then because you times 2, right? So whatever you times there, you need to make it to the power of what? Since you times 3, so it is to the power of 3. So now you just have to substitute the value of Kp here. So 1 over 1.5 times 10 to the power of 3. So you need to the power of 3 there. So hence what you will get is that 1 over 1.5 times 10 to the power of 3, you shall get 6.6667 times 10 to the power of negative 4. So you still have to do the power of 3. So you get the new Kp is actually equivalent to 2.9630 times 10 to the power of negative 10. So this is the first step. Then only you can get the value of Kc for this reaction. Alright, so the calculation that we have done, so the new Kp is equivalent to 2.9630 times 10 to the power of negative 10. Alright, so because you were asked to calculate the Kc, so how are you going to do that? You're going to use the formula Kp equivalent to Kc RT delta N. Okay, so first we need to calculate your delta N beforehand. So delta N is whatever in the product minus whatever in the reactant, provided that it is gas, in gaseous form. So all of these are in gaseous form. Your product is 6 minus your reactant is 9 plus 3. So 6 minus 12, so you get negative 6. That is your delta N. So you have this one already. So your Kp is 2.9630 times 10 to the power of negative 10. So your Kc is the thing that you want to calculate. Your R is 0.0821. And your T, what is your T? Is 400 degrees Celsius. So 400 degrees Celsius plus 273. So make sure that you convert this to Kelvin, because this one is in Kelvin as well. So you should get your Kc is equivalent to 2.9630 times 10 to the power of negative 10 divided by 3.5144 times 10 to the power negative 11. So your Kc is equivalent to 8.4310. So this is the final answer for the third question. Let's move on to the next question. Illustrate and label the enthalpy diagram accordingly for the decomposition of NO2, given that the Kp and the delta S of the reaction are 4.3 times 10 to the power of negative 13 and negative 290 joule over Kelvin mole, respectively, and the reaction was conducted at 25 degrees Celsius with a pressure of 1 atm. In this question, although you were asked to illustrate and label, but before you can illustrate and label, you need to know what is the enthalpy. So, prior to know the enthalpy diagram, you need to know your delta H. So, once you know your delta H, then only you can consider whether it is an exothermic or endothermic process, then only you can illustrate and label your diagram. Alright, before you can calculate your delta H, the first thing that you need to calculate is your delta G. So in order for you to calculate your delta G is equivalent to, your delta G is equivalent to negative RT ln K. So your R is the gas constant, which is 8.314. So the unit shall be in joule per Kelvin mole. And your temperature is 25 degrees Celsius. But since your R is in Kelvin, so 25 plus 273 ln K. What is your K? Is the value of your Kp, which is 4.3 times 10 to the power of negative 13. Right, so all you need to do now is to press your calculator. You should be able to get 2.4776 times 10 to the power of 3 ln 4.3 times 10 to the power of negative 13. So you shall get your delta H is actually equivalent to negative 7.0549 times 10 to the power of 4. Right. So from here, we are going to use your delta G value to calculate your delta H, whereby your delta G is equivalent to delta H minus d delta S. So we are going to do the second calculation after this. Alright, so we are going to calculate your delta H now. So delta G is equivalent to delta H minus D delta S. So we have already calculated the delta G, which is equivalent to negative 7.0549 times 10 to the power of 4 is equivalent to your delta H, the one that you want to calculate, minus T, your T, 25 degrees Celsius. You still need to convert it to Kelvin, plus 273 delta S. So your delta S given in the question is negative 290. So what I'm going to do is I'm going to calculate this, the one in the box bracket first. So you shall get 86420. So in saying that, because this one is negative, so negative will be positive. So positive 86420. So from here you can get your delta H is actually equivalent to, so you bring this to that side, so negative 7.0549 times 10 to the power of 4. So from here you move it there, so minus 86420. So you shall get your delta H is actually equivalent to negative 1.56969 times 10 to the power of 5. So this one shall be in joule per mole. So what you're going to look at is this value. So it means that your delta H is negative, where we know that when your delta H is equivalent to negative, it is an exothermic process. Alright, so from the calculation we already know your delta H is equivalent to negative 1.56969 times 10 to the power of 5, which is an exothermic process. So you shall be able to illustrate the enthalpy diagram. So in the enthalpy diagram, most of you are a little bit confused on the label. Here should be the potential energy, right? Not enthalpy, is potential energy. So since that is in an exothermic process, so the graph should be like this. So what I want you to label is around here, which is your delta H. So supposedly it is equivalent to negative 1.56969 times 10 to the power of 5. So what we are looking at is the shape of the exothermic reaction, the label here, and you need to label your delta H is equivalent to negative 1.56969 times 10 to the power of 5. Right, let's move on to the next question. Calculate the Ka value for 0.2 molar solution of propanoic acid with pH of 4.88. So you know that a propanoic acid is a weak acid, and another way for you to know that it is a weak acid, because you were asked to calculate the Ka, means that it doesn't dissociate completely, so we need to use the ice diagram. Right, the first thing that you need to do is you need to be able to write the balance equation for the dissociation of propanoic acid. So C2H5COOH, because this is a solution, therefore you need to add water to it. So what you can get is C2H5COO minus plus H3O plus. Right, so the next thing you need to do is you need to write the ice diagram. So at the beginning, the molarity is 0.2. Remember, the water is not going to be in your ice diagram. You can just ignore it. And then at the beginning, there is no dissociation occurring, so 0, 0. So because this is not a strong acid, so we don't really know how much it dissociates, so we are going to put X there. So your E will be 0.2 minus X and X and X. This is what happened at the equilibrium. So given to you also is the pH. So pH is actually equivalent to log H plus or log H3O plus, right? So given to you is the pH 4.88 negative log H3O plus for this case. So you can get your concentration of H3O plus is actually equivalent to 10 to the power of negative 4.88. So the concentration of H3O plus for this reaction is actually equivalent to 1.318 times 10 to the power of negative 5. So what you need to do is that your H3O plus is actually the value of X. So you just need to substitute all the value of X to 1.318 times 10 to the power of negative 5. So from your ice diagram, you can know that your Ka is actually equivalent to X times X divided by 0.2 minus X, whereby from the calculation you know that your concentration of H3O plus is actually equivalent to your X. So the value of H3O plus just now is 1.318 times 10 to the power of negative 5. So what we are going to do now is we are going to just to substitute all of the x's with this value. So you have 1.318 times 10 to the power of negative 5 square, because x times x, and then 0.2 minus this value. So you shall get your Ka is actually equivalent to 8.6896 times 10 to the power of negative 10. So this is the final answer for this question. Alright, let's move on to the next question. The Kp of an exothermic reaction of N2 plus 3H2 to produce 2NH3 is 4.34 times 10 to the power of negative 3, with the change in enthalpy of 92.4 kJ per mole when the reaction was carried out at 300 degrees Celsius. Predict if there shall be an increment of the Kp if the temperature was elevated at 600 degrees Celsius. So the first thing that you need to look at when you want to answer this question is that you need to know the reaction is actually an exothermic reaction. Therefore, your delta H is actually negative 92.4 kilojoule per mole. Alright. So another thing that you need to know is you need to know what type of formula that you need to use to answer this question. So the best formula is ln K1 over K2 is equivalent to negative delta H divided by R times 1 over T1 minus 1 over T2. Right. So the next thing that you need to look at is the value of R. So the value of R is 8.314 joule over Kelvin per mole. Alright, so since this one is in joule, this one is in kilojoule, so you need to convert the kilojoule to joule by times 1000. So 1000, so 1, 2, 3, so you should get 92400 joule. Right? So this is your delta H. But since that it is an exothermic process, it should have negative value over there. So now what we are going to do is that we are going to just plug in all the values that we have into the formula. So the formula is again ln K1 over K2 is equivalent to negative delta H divided by R times 1 over T1 minus 1 over T2. Right, so your ln, your K1 is actually this one given in the question, 4.34 times 10 to the power of negative 3. So K2 is the one that you want to calculate, equivalent to negative, your delta H is negative 92400 and your K is 8.314 and the initial temperature is 300, but this one is in Kelvin, right? Your R is in Kelvin as well, so plus 273 minus 1 over final temperature is 600. Again, you need to convert to Kelvin to 73, right? So from here, what you get is your K2, right? So you have your ln 4.34 times 10 to the power of negative 3 over K2 is actually equivalent to 6.6809. So now you're going to remove this ln, so then only it's easier for you to get your K2. So now what we are going to do is to remove the ln there. So what we are going to do is 4.34 times 10 to the power of negative 3 divided by K2 is actually equivalent to epsilon to the power of 6.6809. So you shall get is equivalent to 7.9704 times 10 to the power of 2. So therefore you can get your K2 is actually equivalent to you just have to bring this one up there, so you get 4.34 times 10 to the power of negative 3, so you need to divide back with 7.9704 times 10 to the power of 2, so you will get your K2 is equivalent to 5.4452 times 10 to the power of negative 6. Alright, so from here we need to compare your K1. So your K1 is actually equivalent to this 4.34 times 10 to the power of negative 3. So from here we can say that your K1, right, because it's negative 3, is actually bigger than your K2. Therefore we can say that the higher the temperature, the lower the Kp. So the higher the temperature, the lower the Kp. So that is the final answer for this question. Alright, we are now at the final question for test 2. 100 centimeter cube of water was heated until it reaches 212 Fahrenheit. Calculate the viscosity of the gas coming out from the kettle spout using the Sutherland's formula. Right, so the first thing that you need to do in order to answer this question is that you need to be able to convert this 212 Fahrenheit to degrees Celsius, and then we will proceed to the conversion from degrees Celsius to Kelvin. So the temperature given to you is in Fahrenheit, so you need to convert it to degrees Celsius, so you need to use the formula 9 over 5 temperature in degrees Celsius plus 32. So you know from the question the temperature in Fahrenheit is 212, so 9 over 5 temperature in Kelvin, the one that you want to calculate, plus 32. Therefore you can say that your temperature in Kelvin is equivalent to 100 degrees Celsius. Right, so after that what you need to do is 100 plus 273 is equivalent to 373 Kelvin. So when you look at this, means that 212 Fahrenheit is actually equivalent to 100 degrees Celsius, and the thing that you are heating is water. So now you can actually predict what is the gas coming out from the kettle spout. it should be steam. Right, so from there you can refer to the table given to you and refer to the values for steam. Alright, now we can start to calculate the viscosity of the gas or the steam. So the formula is the mu is equivalent to mu naught times A over B times temperature over temperature naught to the power of 3 over 2. So from here, what you need to do first is you need to calculate the value of A and B. So the formula for calculating value of A is 0.555 T naught is equivalent plus C, so it's equivalent to A. So from the table we can see that your T naught means that the temperature that is the closest to 212 Fahrenheit, which is 100 degrees Celsius, is actually 100. So 100 you need to convert to Kelvin, so 273, we already calculated this before, plus C. So the value of C for steam is actually, the Sutherland constant is 260. So what you can get is 467.0150. Right, so we are going to do the same thing for B, and the formula is actually the same, only that we are going to change from T naught to T, the actual T, the actual temperature, and the value are actually the same. So times 373 plus 260, so you shall get the same exact answer. Right, so since you already have the value of A and B, you already have the value of T and T naught, definitely you can get your the value of mu, which is the viscosity, because given to you this mu naught, which is the gas viscosity, is actually equivalent to 0.0124. So we are just going to substitute this mu naught with the value from your table. So right, so we are going to calculate the viscosity. So viscosity is equivalent to the mu naught times A over B and T over T naught to the power of 3 over 2. So from here, you know that the mu naught is 0.0124, and since your A and B have the same value, so divided by the same value is equivalent to 1, and your temperature T and T naught is also the same, both are 100 degrees Celsius, whereby we have converted to Kelvin, it became 373. So dividing the same number, so you get 1 as well to the power of 3 over 2. So definitely your viscosity is equivalent to 0.0124 Cp. So this is the final answer for the last question in test 2. Alright, so this is the end of this week's video. I hope this video can help you to understand more on how you should tackle all the questions in test 2. So thank you very much for watching this video. I'll see you again next week. Take care, stay safe, and goodbye.